Hello, my name is Kevin Reynolds, and this is our Screencast assignment number 5, where we're going to talk about entropy and the drug. We're going to start off with a brief outline, so we're going to go into entropy, what it is, and kind of what it's going to be doing for us along the way, and then we're going to talk about 3 different concepts. We're going to talk about receptor binding of drugs, membrane diffusion, and then drug properties, all which 2 through 4 are going to be involved with entropy and how entropy is going to be playing a role in each of these. Like mentioned, we're going to talk about entropy, what it is. Basically, the definition is a measure of disorder in a system. So kind of in the little picture on the bottom, you got 6 white dots. When entropy goes up, you have more disorder to the system. So the dots actually begin to spread out, and you get to see this more diverse effects going on. Alright, so kick it off, we're going to start with receptor binding. So what receptor binding is, as you can kind of see in this picture diagram drawn, is that receptors are pieces of a membrane, pieces of a protein, pieces of a system ultimately that take in another part. So in this aspect, or in this kind of theory that we're going to be going over, is how a receptor takes on a drug. So receptors in this situation can be in 2 places, in the membrane or within the cell itself, as you can see with the red figures. Ultimately, what just kind of works and how entropy plays its role is the drug, as you can kind of see up into the top right, how it's really kind of solid, holds shape. When entropy gets in, you actually get disorder to the drug, which allows it to spread out and allows it more ease of access to the receptor, as it can only fit in one place in a particular orientation. It's very important for drugs as it helps raise bioavailability and other properties that we're going to get into a little bit later. So moving right along, we're going to look at membrane diffusion. Basically how this is, in this diagram, we have the membrane, which is going to be our white circular thing. You have the outside and the inside. So outside being on top, inside being on bottom. Ultimately, what we're kind of looking at is how drugs in their normal form are kind of these hard, solid structures, similar to when we looked at the receptors, but they have this issue of moving across the membrane. However, going back to like receptors, when we add entropy to the system, we actually allow the drug to move or disorder a little bit more. So instead of trying to move these entirety of drugs across, we're moving bits and pieces or fragmented forms across, which is ideal, and it kind of follows Le Chatelier's equilibrium process. Lastly, like I mentioned, we're going to talk about drug properties. Like I mentioned earlier, bioavailability, solubility, absorption, volume distribution, clearance rate, those are all important aspects of drugs. But how kind of, or similarly how entropy involves in the system is through lipophilicity, or the combined effects of these all above. Ultimately, what this is getting at is how entropy is adding disorder to the system, and disorder is helping with different things as you're fragmenting down drugs and other molecules to allow them to have the different properties more readily instead of in their solid forms.